Hello, students. So for this week, let's review about ratios. So a ratio is a comparison of two quantities. Comparison of two quantities. And a ratio indicates how many times one number contains another. So for example, I have here 3 highlighters and I got 2 red pens. So if I were to say, how would you compare the number of highlighters to the number of red pens? You're going to say, oh, there's 3 highlighters to 2 red pens. So there's 3 to 2. So you're comparing 2 quantities, right? Now, there's 3 ways to write ratios. It's either you're going to use, first one is the word to. The second one is you're going to use the symbol, the colon symbol. And the last one is you use the fraction notation. Right, a fraction form. So these are the 3 ways to write ratios. Now, a comparison could be part to part, part to whole, or whole to part. What does that mean? So let's have this example. So write the ratio of circles to triangles. On the image here, how many circles do you see? 1, 2, 3, 4, 5. And how many triangles do we see? 1, 2, 3, 4. Now, when you write ratios, order matters. What is mentioned first? It mentioned circles. So let's count the number of circles first. 1, 2, 3, 4, 5. So there's 5 circles for every, how many triangles? 1, 2, 3, 4. 4 triangles. That is an example of part to part. Now, these are the total objects, right? There's part of these objects are triangles and the part are circles. Now, triangles to circles. We already know that triangles is mentioned first. So 1, 2, 3, 4, there's 4 triangles. And how many circles? 1, 2, 3, 4, 5. There's 5 circles. That's another example of part to part. Now let's try objects to triangles. How many objects are here in total? 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's 9 objects to how many triangles? 1, 2, 3, 4. 4. You can also use a fraction form. So this is an example, by the way, of whole to part. The whole number of objects compared to the number of triangles. How about circles and objects? So we got the circles 1, 2, 3, 4, 5. Let's write in fraction form 5 over objects, which is 9. So 5 over 9. That's an example of part to whole. So we're clear about this different type of comparisons. Now, how do we write the value of the ratio and interpreting ratios? What does this mean? Okay, so when you say value of a ratio, it is like a fraction representation of the ratio, okay? So which describes the multiplicative relationship between the quantities of a ratio. I'm going to give you more example later on. So when you say interpreting the ratio, so interpreting the ratio means that you are making a comparative statement about 2 quantities in a ratio. So these are just the definition of these. Now the next one will be the example. So the ratio of apples is mentioned first, to oranges in a bowl is 6 to 2. So find and interpret the value of the ratio. Again, the value of a ratio is a fractional representation of a ratio. So what's the ratio again? The ratio of apples to oranges is 6 to 2. So this represents the apples. And this represents the oranges. Now, what is the value of the ratio? That means write this in fraction form. So you have to put 6 over 2 because apples is mentioned first. So we write it as your numerator, which is the 6. And oranges is mentioned first, which is represented by the quantity 2. So which is your denominator, say 6 over 2. So this is the value of the ratio. But remember, it's a fraction form, so we need to simplify. So if you simplify, what number can evenly divide into 6 and 2? And that's going to be 2. So it's going to be 6 divided by 2 is 3 over 1 or just 3. So the value of the ratio is 3 over 1 or just 3. Now, how do we apply that in the statement below, interpreting the ratio? So the number of apples is 3 times the number of oranges. Okay, so the number of apples is 3 times the number of oranges. So what does that mean? Now, if I were to make a comparison of apples to oranges, do we have more apples or oranges based on this statement? Yes, we do have more apples. So for apples, we have 3 times the number of apples than oranges, meaning for 1 orange, we have 3 apples, right? So what if I have 2 oranges? How many apples would I have? Absolutely, we have 6 apples because apples is 3 times more than oranges. So if we have 2 oranges times 3 gives you 6. If you have 1 orange times 3 gives you 3. So this is how we use the value of the ratio, right? So if you have 3 oranges, how many apples would we have? And you're absolutely right, 9. Now, as you can see, the ratio is still the same. For oranges, we're adding 1. 1 plus 1 is 2. 2 plus 1 is 3. For apples, we're adding 3. 3 plus 3 is 6. 6 plus 3 is 9. So as you can see, we still have the same ratio. The same ratio of 3 over 1, the value of the ratio. So for every 3 apples, we have 1 orange. We'll practice more later on. So next, how about equivalent ratios? When we say equivalent ratios, that means that both numbers in the first ratio is being multiplied or divided by the same number. Don't forget that. To determine if 2 ratios are equivalent, they should be either multiplied or divided by the same number. If they are multiplied or divided by the same factor, that means they are equivalent. For example, it says, determine whether 2 to 5 and 4 to 10 are equivalent ratios. Now, personally, I like to write it as a fraction. 2 to 5, or is that equal to, equivalent to 4 over 10? Now, let's do mental math. What number did you multiply to 2 to get 4? And we say, I multiplied by 2. So if I use the same number, would I get 10 for our second quantities? So times 2, 5 times 2 is 10. So the values are equivalent. So they are equivalent. The ratios are equivalent. Let's try another example. So determine whether 3 over 9, is equal to 27 over 90. Now, let's check. Let's use mental math. What did you multiply to 3 to get 27? And we know we multiply by 9. Now, if you don't know what factor this is, you can always work backwards. You can say 27 divided by 3 is 9. So if I use 9 at the bottom, would that give me 90? No, because 9 times 9 is 81. We're actually multiplying by 10. Are the numbers the same? No, so they're not equivalent. Okay, so hopefully that works. Now let's have more examples. Now, oh, by the way, on the textbook, it has a different way of doing it. They have 2 to 5 and they got 4 to 10. So they're saying 2 times 2 is 4 and 5 times 2 is 10. So almost the same thing. But I just like using the fraction form. Okay? All right, let's have more examples. So, write the ratio and explain what the ratio means. So, fish to birds. So, let's count how many fish there are and to birds. So, fish first. 1, 2, 3, 4, 5, 6. So, there's 6 to birds. 1, 2, 3, 4, 5, 6, 7, 8. 8. So 6 to 8. So there are 6 fish for every 8 birds. So this is writing the ratio and explaining what does it mean. So there's 6 fish for every 8 birds. Now, number 2, birds to fish. So again, order matters. Birds is mentioned first. So we know that there's 8 birds to 6 fish. Now, can you write in the fraction form? Yes, you can. Can you write in a column? Yes, you can. You can say 8 to 6. Okay? So there are 8 birds for every 6 fish. Now, let's move on to the next example. Finding and interpreting the value of the ratio. Bananas to apples. So let's write the ratio first. We'll determine the value of the ratio and we'll interpret the the ratio. So the ratio of bananas, 1, 2, 3, 4, 5, 6, there's 6 bananas, to apples, how many apples are there? 1, 2, 3, 3 apples. So the ratio is 6 to 3. Now, the value of the ratio, again, it's the fractional representation that describes the multiplicative relationship. So 6 over 3, or let's simplify that. What's 6 divided by 3? We can divide it by 3. And that's going to be 2 over 1, or just 2. Right? They're the same. We're dividing this by 3. We're dividing this by 3. Now the question, do we always simplify? And the answer, you already know. Yes, we do. So the number of, what's mentioned first? Bananas is 2 times the number of apples. All right, so the number of bananas is 2 times the number of apples. So if we have 1 apple, we have 2 bananas. If we have 4 bananas, we have how many apples? There's 2 apples. So that's how we interpret the ratio, or the value of the ratio. Now, number 4, the grape bunches and bananas. Oh, well, let's see. So how many grape bunches do we have? 1, 2, 3, 4. So 4, 2. How many bananas do we have again? There's 6. 1, 2, 3, 4, 5, 6. 6. Now, the value of the ratio, write as a fraction. So 4 over 6. Or we can simplify this by dividing by 2. And that should give us 2/3. So that means the number of grape bunches is 2/3 times the number of bananas. There you go. So hope that helps. All right, last page. Woohoo! Almost there. Now, determine whether the ratios are equivalent. So I'm going to show you 2 forms, all right? Let's do what the book says. 1 to 3. Compare that to 5 to 15. So I'm lining them up. Now, what did you multiply to 1 to get 5? And we know it's times 5. What did you multiply to 3 to get 15? And we know it's times 5. Are we using the same number to multiply? Yes. So these ratios are equivalent. Now, do you want to use fraction form? We'll try the fraction form, the fraction notation. So 2/6, is it equal to 3 over 12? So are these 2 ratios equal? Now, as you can already see, 2 becomes a 3, then 6 becomes a 12. We already know that 6 times what gets you 12? 12 times 2. So if we multiply 2 times 2, would that give us 3? That should give us 4, right? So we already know that this is not equivalent. So what if the problem is asking you to fill in the blank so that the ratios are equivalent? So it's asking us that these 2 ratios should be equivalent, but we need to figure out what this is. Okay, now let's try the fraction form. 4 over 7 equal to 12 over blank. Now remember, how do we know which one's the top, which one's the bottom, which one's the denominator and numerator? 4 is mentioned first. 4 is written first, so 4 will be your numerator. And the 7 is mentioned second, or written second, so it's going to be your denominator. Same goes for the second ratio, 12 over blank. Now, mental math. If you don't know what factor to multiply 4 to get 12, you can always use what you have here. It's 12 and 4. So 12 divided by 4 is 3. That means 4 times 3 is 12. Okay, they have the inverse relationship. Don't forget that. So that means if we multiply by 3, if we multiply this by 3, we will get what? 7 times 3 is 21. Now let's try number 8. So we have blank is at top, and 18 is at the bottom, is equal to 5 over 3. Again, can you work backwards? Yes. As you can see, the quantity went down. From 18, it becomes a 3. So that means we are dividing by a number. Or you can also go from right to left. From 3, it becomes 18. So we're multiplying by a number. So what do you want to do? Most of you would probably say, hey, you know what? I can do this. 3 times something gets me 18. Or 18 divided by 3 gets me 6. So 3 times 6 is 18. That means 5 times 6 gives me 30. So the answer is 30. Now remember, these two are already equivalent. So that means we need to use the same number, the same factor to multiply or divide for the first ratio, okay, for the first quantity going to the second quantity. Don't forget that. Word problem using ratios. A middle school band has 45 6th and 7th graders. So this 45 represents the total students. There we go. Oops. 45 represents the total students. And then the ratio of 6th to 7th is 2 to 3. So we already know the 2 represented the 6th grader because it's mentioned first. And the 3 is represented by the 7th graders because it's mentioned second. The question is, how many 6th graders are in the band? So how many 6th graders are in the band? Now, remember, the first thing you need to identify is what are the two quantities we're comparing. We are actually comparing the 6th graders to, is it the 7th grade? No, we're comparing the 6th graders to the total students in the band. Okay, so the total students in the band. Now, what do we know? How many 6th graders do we have? So I usually write it as a fraction. It really helped me out. It's more organized for me. So 6th graders over the total students. Label your values, make it easier. Now, remember, we're finding the equivalent ratios. So it says the ratio of 6th graders to 7th graders is 2 to 3. So that means 6th graders, there's 2 6th graders for every how many total students? Is it 3? No, it's not. Because 3 represents the 7th grade. It should be 5. Because 2 plus 3 gives me 5. Because remember, we're talking about total students. And the 6th graders and to the 7th is 2 to 3. If you add them up, there's 5 students. There's 5 total students in the band for this ratio. If you add them up, 2 to 5. Now it says 45, 6th, and 7th. So where should we put this value 45? Is it on the 6th graders or is it on the total students? It should be under the total students, 45. Now let's use mental math. We're looking for the number of 6th graders if there are 45 total students. So what did we multiply to 5 to get 45? Yes, times 9. 5 times 9 is 45. That means 2 times 9 gives you 18. So you say there are 18 6th grade students for every 45 students. All right. Hopefully that helps.